Hi, I'm Coach Cowland, and in this brief presentation, we'll be looking at kinematics and mathematical modeling for physics. So, what is kinematics? Kinematics is the mathematical modeling of objects in motion. In order to do this mathematical modeling, we'll be looking at variables such as velocity, time, displacement, acceleration, etc. And we'll be looking at those in an algebraic way. We won't need any calculus in order to solve these problems. And when we get to two-dimensional mathematical modeling, two-dimensional kinematics, we will be applying some trig to that. But generally, initially, we will just be using algebra. One of the key skills that we will need is to be able to rearrange kinematic equations to find whichever unknown we don't have. So these are the variables that we deal with. We don't deal with them all in each kinematic equation, just before you panic and think that. And there is a certain amount of overlap. Now, distance, speed, and time go together, and generally speaking, we don't have speed and velocity in the same equations. Um, we use velocity, average velocity, acceleration, and if displacement is in the x direction, we use the variable x, and if displacement is in the y direction, we use the variable y. Note that the units that are on the right hand side, this is significant and should be given in your answers, and the variable should be the case that the variable is given. For example, velocity is a lowercase v, it is not uppercase. Uppercase v is actually volts or potential difference, which is a completely different variable and is also going to be on your equation sheet. Time is another one, which is lowercase. Temperature is uppercase T. Please make a note of these, pause the video if you need to, and make sure that you have them available. These are the four kinematic equations that we use. Now, we don't always use them in this form. Sometimes we rearrange these equations to find the variable that we need. We choose the one that is most appropriate for the question that we have, based on what variables we are given, what information we are given in the problem. This is something that we'll practice and you'll get used to as we go through it. Another twist to this, which is more significant in AP Physics, is that if we are doing something in motion, we may find that one of these variables is missing, but we need to take something from a different area of physics so that we can find the variable and plug it in here. For example, Newton's second law gives us force is equal to mass times acceleration. F equals ma. So we might not have the acceleration of something, but we might need it to solve the problem. But we may be given a force and a mass, and we may need to calculate the acceleration and plug it into one of these. Make a note of these equations. They will also be on your equation sheet. When we are doing mathematics-based problems, I have a rubric and I follow it very closely. It's important that you know what's on it and you understand how to get full marks for each problem. There are 5 parts to it, and here they are. So the first part is to look at a physics problem and to list all of your bits of information. That's worth 1 point. That's 20% of your mark there just from reading and extracting the data. If you know that an object starts at rest, you know that V0 is equal to 0, for example. If you know that the acceleration is acceleration due to gravity, you can write that down as well. It's also important to list what it is that you are looking for, or your unknown variable, so that at the end of the day you give the correct part of your answer. The second part is quite a lot. A diagram, significant figures, scientific notations, and units. If we're dealing with very large numbers, scientific notation is very important. All answers need to have the correct units. A diagram helps you visualize the problem, and the significant figures is used because if we give an answer to 17 significant figures, then that is unrealistic in the accuracy and the precision of our answer. So these things we'll cover in class if we're a little bit rusty on them, but that is your second point. Third, I hate uh, students just giving me the answer to a problem. I want to see where it came from and how you got there, and that you used the correct process to do so. So you need to show your workings and your equations and your steps. I am fine with students skipping steps, but I would like to see where the process started. So showing your workings and your equations is worth another point. That's 3 points before we've got to the correct answer. So the correct answer is the final 2 points. Now this means that it is possible for you to make a good amount of you to get a good amount of points before you've got to your final answer. So even if you are not sure if you've got it right, you can get some of those points in, and it'll just make it a little bit easier. So it's a total of 5 points for each question that we do. Okay? If you have any questions about that, shoot me an email. Okay, thanks for watching.